Now, we want to just recall some of the ideas we've learned about probability when we were in junior school. Now, our basic probability works along these lines. If we've got an event that we want to occur, so we call things that happen events, what the probability of that event will occur was be how many number of ways the event can occur over the total number of all possible outcomes. Now, we often call this our sample space. So that's another word for what can happen. Anything that can happen is part of the sample space. We really need to understand our sample space, and we do a video on that later on. In our notation here, we use P as the writing in the probability, and event as an E, so number of events that occur that are favourable over the number of total events that occur. For probability, we know that we must get something between 0 and 1. So 0 to 100% is only between that. We can't get a probability that's more than 1. If we do, we've got some problem with our calculations. A probability of 0 means the event is impossible. Probability of 1 means the event is certain. Now, hopefully this is all just review. So fractions, we write our probability as a fraction, we said, or you could write it as a decimal or a percentage. Either way, it doesn't matter as long as it is correct. So, but what we try to recommend is, if the information is presented as a fraction, write your answer as a fraction. If it's decimal, put it as a decimal. Or percentage, put it as a percentage. Not that big a deal though. We'll take any answer as long as it's correct. So it doesn't really matter what way we've got it. We try not to write just P is equal to 2/5. We want P with a description of the event, so probability of a 6, or probability of a head, or probability H. So, like we had before, try to write something in there just to signify what the probability is. Again, it's about communication. Majority of questions we'll get in this course will need a diagram. You start to get a little bit more complex. Draw up a diagram or draw up a table. Do something that helps you answer the problem. And remember, that's part of problem solving. What we do need you to know as well are just simple probabilities of some games of chance. You don't need to know roulette, blackjack, but we do need to know what an ordinary pack of playing cards has 52 cards. Spades, clubs, hearts, diamonds. It's not a joke. No jokers in this one. If a question does require a joker, it would explain that in the question. So we need to know those sorts of things. So what are we talking about with our probability? So we've got a box with 23 red, 12 blue, and 17 juggling balls. One's chosen at random. What's the probability it's red? Well, there's 23 favourable out of 52. 50 tickets sold and raffled. Jane buys 5. Probability should win first prize. Well, she's got 5 chances in 50, and we simplify that to 1 in 10. And your calculator does that for you. Notice the probability of a winning ticket, probability of a red. So we're using those ideas. If I threw a coin 10 times and it came up heads each time, so it's more likely to come up tails in the next throw. Is the statement true? Why is it not true? It's not a case of the coin has a memory, and we've got to realise this. It's like, oh wait on, we're due for a tails. No, we're not. The coin doesn't have a memory. It's not tails never fails in New South Wales or things like that. So you've got to realise that there's no memory there. Every time you toss a coin, it's always a half, because it's 50-50 chance. So whether it's come up heads 10 times in a row, the next time it's still got a 50% chance of occurring. This highlights another idea of probability we've got to be clear about. 12 football teams in a competition. So if my favourite team, Tasmanian Tigers, has a probability of 1/12 of winning the competition. So that's not true. All our probability we're going to work on relies on one idea, and that's the idea that teams or events have what we call an equally likely outcome. Now, when we're starting to talk about coins and cards and things like that, then that makes sense because there's no memory. It's all got the same chance. But when we start talking about people or horses or something that does not have the same ability, not everything's an equally likely outcome. So even though there's 12 teams in a competition, not all teams are created equal at the start of a season. So not every team has the same chance of winning. So because they're not equally likely outcomes. So we're really looking for that in your probability every time. So be really careful when you have a problem like that you're not assuming that each team has the same chance, unless you're told they are. But most of the time, it's not an equally likely outcome.